Okay, good morning class. Right. So for today, please log in using the website that I already give. Okay, and also I already give the code there. And maybe for those who use phone, okay, use phone, maybe you can um just scan the QR code here. Alright, for those who just join the class, right? So I will give you again the link and also the code. Okay, for today. Okay, for those who just joined the class, maybe you can use the link, okay, and join the class point, right? Or maybe you just scan the QR code if you want to use your phone. Okay, I will forward the link again. Okay, that's the link. So we wait for another nine students to join. Can just use the QR code to scan, and you will be automatically join the class, the slide. Okay, for those who are just join the class, please use the link. Okay, so I will continue first, right? Uh, okay, so I think on Monday, right? So on Monday, I teach you how to calculate the half life. Okay, so you can calculate if they give you a graph, you can find the half life from the graph. Okay, so example like this, right? So it's starting from 16,000. So half from the 16,000 is 8,000. So you just underline here 8,000, right? And then you go down here, then you just read, okay, how many days, right? Okay, so that is from the graph. Okay, then I will explain again, okay, how to find, okay, the half-life, okay, from, they say they give you the value of the half-life. So how you want to find how much time, okay, for it for how much time that it needs to decay, okay, from certain value to another value, right? So let's say for the first example here, Okay, so I noticed someone just joined. So you can just join the class. Okay. All right, so it says here the half-life of a radioactive substance is 3 days. So means the half-life is 3 days. So what does it mean by half-life is 3 days? So let's say I have example, like I have a 10 gram. Okay, so this is my initial mass. Okay, and then it decays until it becomes 5 gram. So it must be half from the original mass. Okay, so it will take 3 days. Okay, so this is the meaning of the half-life. So from 10 gram to 5 gram, okay, it will take 3 days. Okay, so this is the meaning of the half-life here. Okay, so it says here how much is required for 10 gram of the substance to decay until 1.25 gram is left. Okay, so means this one you have to find out how many half-life will it takes, okay, for the 10 gram of the substance to decay until it become 1.25 only. Okay, so the first one starting from 10 gram. Okay, so remember you have to divide by 2. Okay, because half, right? So you have to divide by 2. Okay, so 10 divided by 2, you will get 5. Okay, and then 5 divided by 2, you will get 2.5. And then another one, you have to divide again, then you will get 1.25. So you can see here, it said it want until it become 1.25. So we already divide 2 until it become 1.25. So the next part, you have to find what is the half-life. How many days will it take? Okay, starting from 10 until it become 1.25. So what you have to do is you have to find how many half-life is there. So how to find how many half-life is there? So we already divide by 2, right? So you just count, okay, 1, 2, 3. So means there are 3 half-life here. So if one half-life is 3 days, so if 3 half-life means 3 times 3, right? So you will get 9 days. So what does it mean by 9 days? So means from 10 gram, okay, if you want to find, let's say the initial mass is 10 gram, okay, then until it become 1.25, okay, it will take like 9 days, okay, from 10 gram to 1.25 gram left. Okay, because you have to remember every time that radioactive reaction occur, the mass will decrease. Okay, the mass will decrease. All right, so that is the example 1. So example 2. So here it said the half-life is 16 hours. Okay, so the half-life is 16 hours. Okay, now it asks you how many of 0.64 gram will left, okay, will left after 64 hours. So this one we have to know how many half-life is there for 64 hours. Okay, so if one half-life is 60 hours, okay, if 64 hours means, so 16, you want to go to 64, you multiply by 4. Okay, you multiply by 4. So this one also you multiply by 4. So mean there are 4 half-life here. Okay, so 4 half-life means you have to divide by 2 4 times, right? So starting from how many gram? From 0.64. So you divide by 2, okay? So this one 0.32, then you divide again by 2, 0.16, then you divide again 0.08, okay, then you divide again 0.04. Okay, so let's see how many half-life is there already. 1, 2, 3, 4. So 4 half-life, right? So means you already found her 64 hours. How many left? So it will be left 0.04 gram only. Okay, so because someone just asked me after the class last week, so I hope you can understand. So you have to you have to find how many half-life is there for 64 hours. So means if there are 4 half-life, you have to divide by 2 4 times. So after that, that is the mass will be left, okay, after 64 hours. So mean after the 64 hours only we left with 0.04 gram. Okay. Maybe some of you just joined the class. Okay, so I give you the link because after this you need to answer the question. Okay, this is for your PBD. Okay, so let's try to answer this one. Okay, I see some of you already submit the answer. Make sure for those who are already joined the class, okay, at the meet, and you also have to join the class point, okay. Teacher, can remove my name again? Okay, wait for a moment. Ang Ying Eng and Brandon Heng, I think. Brandon, I give you another 30 seconds. All right. Okay, so some of you answer B, C, and D. So let's check the answer. So the answer should be B. Okay, so I will discuss this one. Wait for a moment. Which one should I remove? Tan Zia Yang. You only have one name here, right? Or means you want to join again? Tan Zia Yang. Oh, okay. All right, so let's discuss the answer. Okay, what's the half-life of this isotope? So means you can see here it's starting from 100. Okay, so 100, half of the 100 is 50, right? So 50 is around here. Okay, then you underline. Okay, so the answer should be this is 1, this is 2, this is 3. The answer is B actually. Okay, so the answer is B. So okay, so this one the answer is B. All right. Okay, so just find they say this starting from 100. So the half from the 100 is 50. So 50 is here. Okay, and then you just read from the graph here. So this is 5, right? So 1, 2, 3, 4, 5. So when you underline, you can see it goes to 3 days. Okay, so the answer is 3. All right, so let's move on to the next one. Okay, so this one you have to type the answer. What is the answer for this one? Is the process by which unstable atoms emit radiation until they become stable. Okay, 11. Right, so let's check who still didn't give the answer. So radioactive decay or radioactivity, which one? Okay, so if you remember, I said on Monday, right? So they must have the word, if radioactive decay must have the word until it become more stable. Okay, Wei Lun, Jia, Yu Heng, Yan Hei, Pu Yen. Okay, Jia, Wei Lun, Pu Yen. Are you okay? Can type the answer. Okay, I will close the. All right. So the answer should be radioactive decay. Okay, radioactive. Sorry, radioactive decay. Okay, so they must have the word until they become a stable. So from unstable nucleus, okay, it will emit the radioactive radiation until it become more stable. So if for the radioactivity, they just said that this unstable nucleus, okay, and it will emit the radioactive radiation. Okay, they didn't mention until it becomes stable. Okay, so that one is a radioactivity. Okay, very good. Half-life is actually the time taken, okay, for the substance to become half from the original mass. Okay, good. So in. Okay, very good. It's decay, not decomposition. All right. So let's move on to the next one. So what is the half-life? Okay. What is half-life? So I think I just told you the answer just now, right? Okay. Which one? Hyuchi, Kazin, Weilun, Angelina, Mingdong, Ying En, Wugui, Peiling, Ziyu, Yuchi, Guyan, Xiaoyang. Xiaoyang you have to name again. Just write A, B, C or D only. Okay. Pei Yang Pei. Oh, okay. Where is Weilun? Are you there, Weilun? Yup, Weilun. Just now also you didn't answer, right? Okay, so let's check the answer here. So what is a half-life? So half-life is actually the amount of time it takes for half of the nuclei in the sample of the isotope to decay. So it must be half of it. So just now if I say start from 10 gram, right? So you divide by 2, it becomes 5 grams. So it must be half than 10 gram. Okay, so that's why we call it half-life. Okay, so the answer should be C. Okay, it's not about the electrons. Okay, we didn't divide the electron. We divide usually the mass or the nuclei. Okay, the nucleus, right? Not the electron. Okay, so the answer should be C. Only one answer, Yikhe. Okay, we didn't divide the electron, we divide the nucleus. Okay, because you already know nucleus, they consist of proton and neutron. Electron is outside from the okay. Okay, so the answer should be C. Okay, nucleus, or maybe sometimes it said original mass, original activity. Okay, something like that. Okay, but we didn't divide the electron. Okay, so you have to know that actually in the atom. Okay, after this we will learn about this one. Okay, so there is a nucleus. So nucleus, yeah, consists of positive charges and also the proton and also neutron. Okay, and then surround it, okay, there will be the electron. So here what happened in the radioactive decay, we divide the nucleus. The nucleus is the nucleus is the one is not stable, right? So we divide the nucleus, not the electron. Okay, right, so let's try for this one. So it says the half-life of zinc, okay, zinc, Zn is zinc, okay, is 2.4 minutes. Okay, so zinc's 2.4 minutes. So if one had 100 gram at the beginning, so means the initial mass is 100 gram. So how many gram will be left after 2.4 minutes has elapsed? So if you have to know how many half-life is there, okay, how many half-life is there? So 2.4 minutes is one half-life. So how many half-life is there? Then let's say if one half-life means you only have to divide two once. Okay, but let's say there are, just now the example that we did, they have four half-life, right? So we have to divide by two four times. Then you will get how many the mass that will be left, okay, at the end of the reaction. Okay, let's see who still didn't give the answer. Okay, Mak Cik Tong, Ying En, and Yang Pei Ying. Okay, I give you 30 seconds more to answer. Oh, okay. Mak Cik Tong, are you here? Okay, so some of you answer C. Okay, so many of you answer C. All right, so let's check the answer. Which one is correct? So it says here the half-life is 2.4 minute, right? So I put it already. Half-life is 2.4. So it says have initial mass is 100 gram. Okay, 100 grams. So it asks you how many gram will be left after 2.4. So means 2.4 means after one half-life. So you have only to divide the mass, okay, only once. Okay, divide by 2. So 100 gram divide by 2, you will get 50 gram. So the answer should be C. Okay. All right. So good. Okay. So the answer should be C. Okay, we move on to the next one. Okay, this one already done. Okay, so we move on to the next subtopic, that is a atom and nucleus. So this is actually example of the carbon atom. So just now I already explained to you that actually this is the nucleus. Okay, so the nucleus actually consists of the proton and also the neutron. Okay, so that's why the nucleus, the charge is positive. Okay, so neutron, they don't have any charge. Okay, they don't have any charge. So means at the nucleus here, the charge is positive and it surrounds by the electron here. Okay, so the electron, it depends on how many electrovalence, okay, for the atom, right? So okay, atom and nucleus. So atom is the smallest particle and cannot be further divided, right? That is the smallest particle. So atom is the smallest particle and it cannot be divided. Alright, development of science finding particles smaller than atom, okay, called proton, electron, and neutron. So development of science, they find actually there is smaller particle, okay, than atom. Okay, there is we call it as a proton, electron, and neutron. Okay, so proton is basically is a positive charge. Electron is a negative charge while neutron is a neutral. Okay. So when number of proton in atom is equals, okay, the number of electron is equal. Okay, so if the number of proton and the number of electron is equal, the atom is neutral. Okay, so let's say if I have the 16 proton and 16 electron. Okay, so means this, we call it the atom is neutral. Okay, the number of proton and electron must be same, so we call that atom is neutral. So atom consists of electron, proton and neutron. So formation of positive ion and negative ion. Okay, so positive ion we call it as a cation. Okay, positive ion we call it as a cation, while the negative ion we call it as a anion. Okay, so positive ion cation. Okay, negative ion we call it as anion. So positive ion, what is the positive ion? So positive ion is the atom that lost the electron, okay, and it will form a positive ion. Okay, so any atom that lose the electron, okay, we call it as a positive ion. Okay, so let's say initial I have a 16 electron. Okay, then maybe after that, okay, one electron go out. Okay, so now it will be left with 15 electron. So since it lost one electron, so the atom we call it as the positive ion, okay, or cation. Okay, for the negative ion, all right, so the atom that gains electron, okay, we call it as a negative ion. Okay, any atom that receives the electron, okay, there will be have more electron than the proton, right? Okay, so there will be charged negative, so become negative ion or anion. Okay, so what you have to remember here, okay, for loose electron, then we have a positive, we will produce the positive, we call it as a cation. Okay, for the atom that gains electron, okay, we produce the negative ion and we form the anion here. Okay, so this one you have to know. All right, so if let's say the electron has the more than, let's say they have a 16 electron just now, like I said, so it lose one electron means it already lost one negative charge, so now it will become positive. All right, so for those who are, let's say this one, they are 60 electron, then it receive one electron, so now it become 17 electron, right? So it has more electron, so it become negative charge, right, or negative ion. So it have an ion, or we call it as a an ion. All right, so when atom lose or gain electron, the atom become a, okay, so when atom lose or gains electron, the atom become a charged particle known as ion. So any atom that lose or receive the electron, it will become charged particle. So that charged particle, we call it as ion. So this one we already discussed. The positive ion means it lose the electron. So this is the example. Okay, so this is the number of the neutron, okay, and neutron no charge, so means 0 here. So the proton is 11, is positive 11 because the positive charge, proton is a positive charge, while electron is a negative charge, so negative 11 here, right? So when you lose one electron, okay, so the number of electron will decrease, right? It will become 10. Okay, so means the charge also become negative 10. So what you can see here, the number of proton is higher. So remember I said just now proton charge is positive. Okay, so maybe I can put here charge positive, electron negative. Okay, this one positive, electron negative. Okay, so you can see the number of charge of proton here is higher than electron. So that's why they produce the cation, or we call it as a positive ion. Right? See, the number of proton is more than the number of electron, since the electron lose, right, one electron here. Okay, so this is a positive ion. So let's say for the negative one. Okay, so for negative, let's say if I have the oxygen. Okay, oxygen is a negative, is oxygen here. Okay, oxygen is 16. Okay, so proton, all right, proton have 16 and electron also they got 16. Okay, so this one is for the atom oxygen. Okay, then after that they say it receive, okay, it receive the electron. Okay, receive electron. Okay, so when it receive electron, what happened to the number of electron? It becomes 17, right? While the proton still become 16. Right, so what happened here? You can see the number of electron here is higher than the number of proton. So now the oxygen will become the negative ion, okay, or we call it as a N ion, okay, because the number of electron is higher than the number of proton. Okay, just now like natrium, you can see the number of proton here is higher than electron. So that's why it become the positive ion, because the positive charge is more than the negative charge, right? So remember, proton is positive, electron is negative. Neutron, no charge. Okay. Okay, so let's try to answer for this question. So what do we call the tiny core at the center of an atom? I already draw for you, right? There is center of the atom, they got what, okay, at the center, and then it will surround by what? Okay, West Kenyan, Wei Lun, Yinxi, Jia, Yang Peiying. Wang Yingxi, Yang Peiying. Oh, you have two names, is it Yang Peiying? Can type. Okay, can you please just type your answer in chat? Peiying, you got two names, is it? Oh, okay. So many of you got answer B and D. Okay, so let's check the answer. Alright, so what do we call the tiny core at the center of an atom? So means here. Okay, so this one we call it as a nucleus. Okay, tiny core is the nucleus, right? So inside the nucleus here, right, they consist of proton and neutron. Okay, and this one we call it as a electron. This is actually the 3D image for the atom. Right, so the answer should be D, donkey. Okay. So let's go to the next question. So which particle make up the nucleus of an atom? So means this one you can choose more than one answer. Sorry, more than one answer. The answer is D. You see, I already told you just now. I redraw for you what is inside of the nucleus. Nucleus. Okay, can Shen Yan He Ji Yu Yu Chi Puyen. Okay, Ziyu, are you okay? All right. Okay, so many of you answer C. Okay, some of you answer E also. Okay, to you actually there are two answers for this one. Okay, so what's the answer for this one is actually for nucleus there are consists of proton and neutron. So the answer is A and C. Okay, the answer is A and C. Okay, so maybe some of you they choose A but they didn't choose C. Okay, I told you already there are two answers for this question. So the answer is A and C. Okay, so how about this one? What is the positive charge particle of an atom? Hmm. Okay, so let's check who still did answer this question. Okay, Yuen, Jiu, Puyen. Puyen? Okay, I give you 10 seconds. After that, I will close. Okay. All right. So the positive charge particle of an atom, okay, is actually proton. Okay. So inside of this, I already told you they got proton and neutron. Okay. Proton is positive, neutron is negative. Okay. So proton, the answer is B, boy. Okay. All right. Very good. Okay. Some answer A, no. Proton is positive, electron is negative. Okay, neutron no charge. Okay, very good. So for this one, so this one is proton and neutron. If you cannot see the answer. Hmm. Okay, the negatively charged particle of an atom are so there are three types. Okay, so proton, neutron, and electron. So which one have the negative charge? Oops. All right, so Tendong, Qingyi, Kenshin, Jiyu. Oh, Kenshin, Jiyu. Okay. All right, so the negative charge particles of an atom, of course, it will be electron. Okay, so the answer is A. Dia je answer B. B is proton. Proton is positive charge. Okay. Proton positive charge, electron negative charge. Okay. All right, so let's try this one. So an atom become what when it gains electron? So just now, like I give you example, for oxygen, right? It receive one electron. So what will happen to the oxygen? The number of what will increase? Okay, so who still did the answer? Brandon, Xiao Yang or Xiao Yang, see you. Okay. Alright, so an atom became what when it gains electrons? So any atom that receives the electron, okay, means it will have more electron. So more electron, it will have the negative charge. Okay, remember when I said just now for oxygen, right? So oxygen, they have 16 proton and 16 electron. Okay, the number of proton and electron are same, right? Means they are neutral at that time. Okay, then after that, you will gain electron. So when you gain the electron, so now the electron is 17, right? And the proton is still 16. So you can see they have more electron if you compare with the number of proton. So more electron means now it will become negative charge. So negative is actually, we call it as an ion. So the answer is B, boy. Okay. You can see the atom is neutral if the number of proton and electron is same. If the number of proton and electron is same, then we call it neutral. But now the number of proton and electron is not same anymore because it received the electron. So it will have the more electron number than number of proton. So it will have the negative charge. Okay. But let's say if they lost the electron, okay, just now we see the natrium, right? The example of natrium. So natrium, let's say the natrium is 11. Okay, it has 11 proton and 11 electron. So when it lost one electron, okay, it lost one electron. Now the number of proton still same, okay, but the number of electron you can see it become 10. So what you have here, the number of proton is higher than number of electron. And you already know the proton is a positive charge, right? So mean they have more positive charge if you compare with the negative charge. So that's why for this one, when it lose the electron, it will become the positive ion. Okay, so the answer should be B, boy. Okay, very good. Not neutral because there's have a change of electron there. Okay. Neutral is proton same as, oh sorry, I mark. Okay, very good. For this one, it lost electron. So what will happen? Mm. Okay, Wei Lun, Jia Jia, Yu Heng, Puyen. Okay. Okay. An atom become what? So it will become positive. So the answer is A. Okay. Ugui, so many A here. Are you mad? Are you mad at me? Okay, very good. But some of you also say answer D or C. So loss of electron means if we charge positive, receive electron charge negative. Okay, so I will stop until now. So we will continue on Monday. All right. So take care, class, and thank you for joining my class. Okay, so have a good weekend. Okay, bye. Okay, welcome. Bye bye.